All right, here is problem 29. In 29 we have a weight, a 5 kilogram weight that's being lowered by a string onto a spring. Okay? And the situation is you have a scale built into the spring. So this is really just reading the tension in the rope here. Okay? That's what it does. It measures the tension in the rope as we lower this on to here. Notice we're lowering it slowly. We're not dropping it. That would change things. For part A, we want to know what the scale reads just before the mass touches the spring. So essentially, before it even touches this, we want to know what this is reading. Well, this is very easy because for part A, so I'm doing part A, we have our free body diagram. We got tension this way. We got mg this way. We're lowering it at constant speed. So we have that the F net y is equal to tension minus mg, and this is going at constant velocity, so the tension is just mg, and so the tension is just going to be equal to 5 times 9.8, which is equal to 49 newtons. So for part A, that's very easy to do. Okay. Now let's do part B. Part B says the scale reads 20 newtons, that's this scale up here, reads 20 newtons, so the tension is 20 newtons, when the lower spring has been compressed by 2 centimeters. What is the value of the spring constant? Alright, so we got to do another free body diagram here. We got tension going up, right? We got gravity going down, and we got the spring force. But the spring force is which way? The spring force, once you start to compress this, the spring force is pushing back up. So the spring force is also going this way. So now we're going to do F net y again. We're going to have tension plus the spring force minus mg is equal to F net y. And so what we want to do is solve for the spring constant. Okay? Now, this is going to be equal to 0. But this is where we got to be careful here because it's kind of tricky. Because the spring force, remember, is already going in this direction. We already have it applying upward. So when it's applying upward like this, we need to take into account, because normally we replace the spring force with equal to negative kx. But the negative is telling us the direction. So here, we're going to put this in. We're going to put it in as negative ks, but we got to be careful about which way x is, whether we put it in as positive or negative. Does that make sense? All right, so stay with me. So I'm going to go 0 is equal to tension minus kx minus mg. Okay, and we want to solve this for k. So I'm going to move this over this side. So I got kx is equal to tension minus mg, and k is equal to the tension minus mg over x. Okay, well, now I know these things. The tension, we already said that the tension is equal to 20 newtons. So this is 20 minus the mg, but mg we know is already 49. Okay, this is where we got to be careful. Is x positive or negative? Well, we had positive going up, but the spring is compressed downward, so this actually becomes negative, and this is in centimeters, so I have to put this as negative 0.2. Okay, k, when you do k should always come out as a positive number. And you get 1,450 newtons per meter for part B. So be careful about that. Notice I always replace this with minus ks, the spring, but I got to be careful about what I put in for x, the direction. Okay, part C then says, at what compression will the scale read 0? Well, if the scale reads 0, that means there's no tension. So our free body diagram just becomes mg this way and the spring force this way. Essentially, the spring force has to balance gravity. So in F net y, I got Fs is equal to, or minus mg is equal to F net y. This is equal to 0 because it's balanced. The spring force is equal to mg, right? But this is minus kx is equal to mg. And I can say x is equal to mg over negative k. By the way, I should have said up here, K is always positive. If you get negative value, you did something wrong. Okay, so X is equal to mg, which is 49, over negative 1,450. And when you do that, you get 0.034 meters, or 3.4 centimeters, which is the answer to part C. And that's how you do number 29.